Oh, Jesus. Big neck of chicken. Damn close, ain't it? That here.
Good morning, guys. Today's project is going to be something a little unusual for me. It's called a chicken plucker. I had a friend come to me the other day and asked me if I could build him a chicken plucker. I'm an engineer, not a farmer. I had no idea what that was. I thought that was something Grandma and Grandpa did, and I had no idea. Anyway, okay, well, I need some pneumatics, I need servos, I need CPU, I need stainless steel, I need compressed air source, and that's my first thought as an engineer. That's kind of how you think. But you want simple. Anyway, he said, no, look on YouTube, you'll see them. They're easy to make. Of course, I don't know how easy because I'm the one making it, not him. Nonetheless, I looked at YouTube and I found, sure enough, there's some really great things out there called chicken pluckers. Most of them are based on the barrel design. I think pretty much, I looked at 6 or 8 videos. And so I'm gonna do a barrel design. But the ones I looked at, a lot of them have some serious flaws with them. One, they use wooden frames. Now, most of these people that are on YouTube, and my friend in particular, he's going to do this regularly. So he needs something that's going to last. And wood is not really well suited for that. It means you're just going to have to be rebuilding these things periodically. But you don't want too much metal unless you're using stainless. First off, it's going to be heavy, it's going to be expensive, and it's going to be corrosive. This is something we don't want. After looking at all the options out there and all the different designs, I came up on some basic things I have to do. Number one, I do not know wood frame. Mostly plastic. Should be safe. It's going to have 110 running to it. Got to be very safe. Very, very, very safe. It's got to be well built so that it will last for many, many years without any trouble. Okay? And of course, it's got to be efficient and easy to move. All these things. So here's what I come up with. I'm going to use a standard 55-gallon classic drum. This one contained concentrated drink base. Smells good when you open it. Smells kind of fruity. Anyway, what I'm going to do, this barrel has got a really, really strong lip at the top. Remember, these things are designed to carry 400 to 500 pounds and stack. So, the bottom, of course, has got this nice rolled edge. So what I'm going to do is I'm going to roll this baby over and make the bottom the top. So here's the basic plan. Basic plan is this. I'm going to take and cut the bottom out, or the top, and I'm going to leave about a 1-inch lip all the way around the drum. Okay? The drum's 35 inches tall. About 20 inches down, I'm going to put a polycarbonate partition that'll separate the upper part of the drum from the lower part. And of course, I'm going to put the chicken finger plate for lack of a better word. I don't know what the heck you call it, but the thing you mount the little rubber chicken fingers to. All right. Of course, you'll have a spindle assembly and a pillow block bearing, a shaft. You'll have a pulley of some undetermined dimension yet. I'm still working out numbers on it. And then a bottom pillow block to support the bearing. Couple of things over on one side of the bearing, or the barrel. I'm going to have a chute cut in the side for the spoilage. Got to have a place to get those feathers out, of course. I don't want them to fall through. The bottom of the barrel, I'm going to cut the complete top out of the barrel, or the bottom, the original bottom. That'll be removed so it's open for drainage. And then along the sides, I'll cut some openings just to help the drainage. I'm going to bend some tubing and mount a frame, kind of like a hand truck, a light mover's dolly. Now I might just go ahead and buy a cheap mover's dolly. I can get one for about $30 at Harbor Freight and modify it. But this purpose of this guy will be to allow you to move the barrel, have wheels on it. It'll also give me a nice secure mount for the motor. Okay? And we'll put a pulley there of some undetermined size, and there's our belt drive. And of course the fingers will mount along the side, just like you've seen in all those drawings. If you're looking at this video, you already looked at other videos. The goal here is something that he can use and it will last a long time and not be horribly expensive to build. Motor's a 1/3 horse. I think that's a minimum rating we'll need for a motor. The fingers, about 100, 150 fingers is what we'll be using. Along the top of inside this lip, I'm going to put a piece of 3/4 inch PEX tubing in a loop and drill some appropriately oriented holes to jet the water down over the chicken and the fingers to lubricate and wash all the spoilage out. And we'll tee off on the back side here somewhere and come out with probably a standard garden connector with a valve on it. You get these at Lowe's and Home Depot. That'll give us a water cutoff valve and a quick connect. All right. And of course we'll have a safety cover. Safety cover will keep the water off the motor, give us a nice drip edge so that we can avoid electrocuting ourselves, hopefully. And some type of functional switch that can work in a wet environment without the risk of electrocuting a buddy. Anyway, that's the basic plan. I've never built anything like this before. I've built lots of different systems. I've designed many systems over the years, but I have to give my friend the credit. He really threw something interesting at me that I think I'm going to enjoy building quite a bit. The main thing of this is I want it to last. I want it to be well built so it'll be trouble-free operation, easy to service when needed, and something that you can move around easily and store. No, like I said, no wood on this. I don't want any wood. That's just going to be a problem. But the metal, I have to consider the rusting and the oxidation of the metal. So those are things I got to concern myself with. I'm going to engineer this thing on the fly, but this is the basic plan. And like I said, there are all you guys out there that are on YouTube that have looked at chicken pluckers based on a barrel design. I'm not doing anything radical here. It's pretty much a time-tested design. The only difference is on this one, I'm keeping the barrel intact. I don't want to cut off part of the barrel and have to build a frame and all these things. Simplify the engineering on it, simplify the design, keep as much of the barrel as possible, removing as little of the barrel so we don't sacrifice the strength. Remember, we're going to have I don't know what a chicken weighs, 4 or 5 pounds maybe, big chicken. Going to be tumbling around in there, maybe 2 or 3 chickens. That's a lot of energy bouncing around inside there. Now, granted, it is a chicken, but we still have to keep this thing stable in its function. Like I said, I don't know the diameter of the pulleys yet, so this ratio, the drive ratio in the motor, 1/3 seems to be a minimum horsepower. That's what I got to work with. We'll see. So thanks for watching this much, and let's get started with it. Well, this is always the most nerve-wracking part, the point of no return. Let's drill our first hole. Now, I'd like to say a note about safety. Never cut into a container unless you absolutely know what was in it. The risk of your life or serious bodily injury cannot be stressed enough. You never know what you'll find in there. Here I'm just drilling the holes to set the reference points for the mounts for the upper water tube. And now what we're doing is I'm cutting out the bottom. I'm cutting out, so I'm leaving a cross brace in there. This is where the bottom pillar block will be, bearing block will be bolted. It also gives good drainage. You notice I'm leaving the heavy-duty rim of the barrel. That'll keep the strength I want, and it give it a little more stable characteristics when it's sitting on the ground. Remember, we're going to be shaking a 8 to 10 pound chicken, or maybe 2 or 3 if they do 2 or 3 at a time. So you now want a nice stable and broad base, and that rim will really anchor it to the ground. It won't slide around. If I'd used the soft side or the round end, it would have moved around too much. Now here these are just plastic snap PEX clamps. You anchor them to the wall and snap the PEX in. They work really, really nice. I'm using a pop rivet, and I'm using a backer washer on the inside of the rivet, or on the inside of the PEX clamp. You can see right there. Kind of fast. Alright, this is a piece of 3/4 inch conduit that I rolled so that it fits over the top of the barrel, and then another piece of 3/4 inch conduit that I bent into a handle shape. There, it's been cut and welded together so it's solid. It just slips over the barrel. It doesn't actually mount to the barrel in any way. It's just a friction fit. It'll help give it some additional strength up there. Once I cut it open, I felt it was just a little too flimsy. Now I've clamped the handle up there, and I'm going to tack weld it. Yeah, see, it comes off very easily. There'll be a couple bolts holding it on. I'll show you those later. But see, it just comes off, slides over. The wheels will get mounted to the back of it. I'm going to put a couple of 1/4 bolts near the bottom, and that's actually what physically connects the metal frame to the barrel. Just 2 little bolts, and the rest is just friction from that upper ring. It's strong and simple. If for some reason you ever need to change the barrel, take the belt off, disconnect the water line, 2 bolts. Easy peasy. Here's just a couple of lawnmower wheels I had laying around. I mounted them up to a couple pieces of triangle. Oh, here you can see the how the tubing, the PEX tubing, is attached. Now, like I said, the ring is not physically connected to the barrel. It only cradles it. Gives a nice friction fit. Right after I tack welded the handle, I discovered I was out of gas. So I had to switch over to flux core wire because it was Saturday and the welding supply place is not open. Got most of the galvanizing off, but there's a little bit there when I was tacking it together. The wheels are just 3/8 inch rod run through a piece of 1/2 inch steel tubing. I got a little piece of CPVC as a spacer for the wheel. Used a 3/8 inch nylock nut on the outside, so they won't come loose. All this stuff is basically tack welded right now. It's a little sloppy right there. It's not bad. And you can see the 1/4 inch bolt that holds everything together. Like I said, it's just 2 1/4 inch bolts. Anyway, we're still in initial fabrication, so we'll take it all apart when I got everything positioned where I want. And do a final welding and dressing the welds and coat of paint on it. You know, we got about 2 inch gap when you tilt the thing for rolling. You got plenty of gap there so that it's easy to move around. And there's the bolt. See the flashing and such. I didn't get all the galvanized off when I welded it. You always want to do that. I don't know how I missed it, but nonetheless, that's what it did. The stuff is nasty on you, so you don't want to breathe it. You can see the spattering from the bloody flex core. You wouldn't normally get that with gas, but when you run out, and I wanted to keep working on it. All right, this top plate here, this is a 1/2 inch thick piece of polycarbonate. I forget what it is. I think it's nylon. And I'm using number 10 stainless steel 1 inch, 1.25 inch stainless steel screws. Now here I'm positioning. Oh, let's go into a rant for a second. I don't buy fasteners from the big box stores. Everything I buy, unless it's an emergency and I need it and I can't get it because of the date or the time, I like Fastenal as my industrial supplier. I buy in bulk. I always have leftovers, but they have traceable standards. You don't ever have to worry about your fasteners failing. You get them at a big box store and more than likely they're junk. So here I'm bolting down the upper bearing block to the partition wall. It's really important to get everything centered. There you can see all the little stainless steel screws that hold it in place. Now I'm just aligning the bottom bearing block, and this is really pretty critical. If you get this off, your platen's going to be crooked, it's going to be rubbing against the wall, it's going to give you all kinds of grief. So measure, 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 measure. And to allow for variance, this one I'm using 5/16 bolts with 3/8 inch holes, and of course I'll be using nylocks. This is just fabrication hardware. This is not production hardware. But that allows me to shift the bearing block around as much as 1/8 of an inch. That'll help me maintain any misalignment problems that might occur. There it is. There's all them stainless steel screws. I put so many holes in this thing. Now here's the pulley I found. I'm just checking to make sure it's true. It had a couple of bends in it. This is a flange I welded up on the shaft. Now that flange, what I did is I bought a 1/2 inch gas pipe flange, and I bored it out, slid the pipe in there, and then welded it. Made perfect. Now I'm using T6 aluminum. It's a good quality general purpose aluminum. It's good strong. It's an alloy, so it's a little stronger than regular aluminum, or just the general purpose. But actually I'm using it because I had it in stock. So I've cut the circle to the dimensions I want. Now I've got to figure out how I want to put these chicken fingers. How do I orient them? So I determined the diameter of the circles and the number of chicken fingers. Now the fun part begins. Drill a pilot hole, then I'll make a larger hole, then I'm going to use a unibit to set the final dimension. Yeah, this gets old really quick. I could have done it on the drill press, but I was out here working, so this is just as fast. And I don't have to worry about cleaning up the floor of my machine shop. Anyway, as you can see, there's 4 concentric rings and they're staggered. Alright, now I'm going to 3/8 inch bit just to give myself a little more clearance with that unibit. Yep, that got old. Alright. We're going to let it cool down. Drill, drill, drill.
We're going to let it cool down.
Yeah, drill got a little warm. That's a new Lowe's drill I bought. It's 24 volt brushless. Very powerful, very torquey. I drilled all those holes on one battery. Pretty impressive. Well, that's 3/16 aluminum plate, by the way. Alright, now we get the next thing that's so much fun. Installation of chicken fingers. This gets old pretty quick too. Now these are coming in on the back side. What these 3 that are facing up, when everything else is facing down, actually the plate's inverted. The 3 that are you see right there facing up are actually going to be on the bottom side of the thing. And as it spins, it's oriented so that it will push the or at least migrate the chicken the chicken feathers to the outer wall and then eventually to the chute where they'll be washed out of the drum so they won't accumulate inside. At least that's the plan. Yep, they're fun. If you ever build one of these things, you're going to see what I mean. I considered using stainless for this, but it really would have been excessive and overkill. There's the plate. Mounting the flange and the drive axle. And we'll get that puppy installed. There's the pillar block bearing. Sit in there. Drop it in. Spins. Nice. Look at that. Okay, next set of holes. This is the holes for the outer fingers on the wall. And again, I basically did the same thing. I calculated the distance apart around the circumference, and then I staggered 3 rows. After testing, we later decided we add a 4th row, again staggered a little lower to the platen, because occasionally the chicken leg would get caught in there, and it would break the leg when it was tumbling around. So the extra row prevented that. Okay, back to the unibit. At least it's plastic. It cuts pretty easy. That doesn't mean it's any more fun. But to be honest, this was such a fun project to work on. It's so different. Very enjoyable. I had fun doing it for my friend. Alright, more fingers. I won't say too much so you can enjoy the show. I mean, if I had to put these all in these holes, you could at least watch. Yeah, anyway, the bottom row, I added 1 more row just below that. So it was just maybe an 1/8 inch above the platens row. And the idea there is it can't get, the chicken leg won't get inside there. See how that just slides over there? There's the motor all mounted on there. And this is a test run. Now this is slow motion. It's not actually, it's not the actual speed. I've slowed it down to 1/10. It's actually running at I think 300 RPMs. And this is my calibrated mass. It's a bowling ball. The reason I did this is I wanted to see how it interacted. It's a 10-pound ball, so it's a little heavier than your chicken. And I figured that'd be a good stress test. But I wanted to see how the ball interacted with the fingers. And you can, if you watch closely as it rotates around, you can see that the fingers slide up the ball and then slide back the ball. And those ribs, I can see how these things will work really well for pulling the feathers off the bird. The issue, of course, if you run it too long or too hard, you can tear the skin. And that's one of the things we found is the temperature of the water and the duration that the chicken is in the hot water is super critical. Not long enough, you're not going to get the feathers out or get them all out. Too long and you damage the skin and it tears the skin. So there is a very, very fine balance. Like I said, this is a 10-pound ball. It's a little heavy for this, but it proved the functionality. And I thought you'd like to see the slow motion shot. I did it just to study it. But you can see how the fingers are working nicely. The upper row of fingers are not interacting at all, but they're planning to use this thing on a turkey. So the upper row of fingers are probably pretty critical when you get such a large animal in there. Now, they won't be using it on the turkey till closer to November, but still, it's going to be an interesting thing to observe. I will videotape it and repost how it worked with the turkey. Now you can see the red tube up there. That's the PEX water line, and we have the water turned off at the moment just so we can get a good visual on how the ball is tumbling around inside there. It works really well. It does cause the plucker to shake a little bit, but again, that's a lot of mass. Remember, we're moving about 300 RPMs, and you got a 10 ball running around on a 20-inch circumference, or a 20-inch diameter platen. That's a lot of energy. What I should have done is put a little classical music set with this. That would be kind of neat. Maybe next time. Anyway, we're about done. I didn't get much of a overview of the thing. I painted the steel red Rust-Oleum. Also, the water feed on this is, I have a electric valve, so when you turn the motor on, the water will automatically turn on and start showering the bird as it spins around there. You want plenty of water because you want that stuff to slide, and water's a good lubricant. You also need it to flush out the feathers. And you can see on the lower left part of the screen there, that's the chute where the feathers will come out. And those fingers underneath worked really well to move the feathers out. Now this ball was so heavy it did knock a couple of the chicken fingers loose from the lower platen, but that was easy to correct. That was minor. After we made the correction, we had no more loose fingers. There it is. Nice slow motion effect. You can see those two loose fingers there. Okay. Here's the belt. I used a link belt, and we ended up going up to a 1 horsepower motor. Now there's your on-off switch. Using again a PEX clamp to hold it in place. That's just CPVC, and that makes it easy to hit it with your hand. Remember, you're going to be doing these chickens. It's just going to be nasty, messy. You're going to have gloves on, and everything's uncovered here so you can see how it works. This is just a pump stroke switch, just designed to get wet. And here's the final result. If you've ever seen the movie Dune, it kind of looks like a sandworm, don't it? Seems to be pretty consistent. Thanks for watching.
Still good? No, don't put your fingers in front of it, honey.
All right, hit stop. All right, hit stop.